All right, guys, here I am with the first video in this unit of triangles. And like I have said in the remind mostly, because I didn't really have time to talk about it in class, this is how we're going to run this unit. I'm going to give you the notes at home, and then you're going to fill those notes out. The PDF is already posted on Edsby for you to look at. If you don't want to hear my voice and have me teach you, that's totally okay. So that way in class we can just have more one-on-one practice time. Like, if you have questions, I can answer them right then and there instead of you waiting for me to stop talking in class. So let's just get on with it. So I've already filled out some of these notes because classifying triangles is quite simple. It's just giving names to triangles based on their angles. So acute, obtuse, right, and equiangular triangles. That word is a little weird, right? Equiangular. But what you need to know is that this prefix equi just means equal. Angular, hopefully you understand, angular refers to angles. There we go. It's just like equilateral or equidistant. Equal lengths, equal distance, all that good stuff. All right. I also did this by sides, so a three congruent side triangle is equilateral. If we have two congruent sides, that's isosceles. No congruent sides, that is a scalene. Notice these little tick marks on the side. That means all of those sides with one tick mark are all the same. These two sides right here, those are congruent to one another with that base not being congruent to the other. So like I have up here, not all the problems are going to be covered in this video, so we're just going to do a few and move on. If you have questions or if you want all of them worked out, you can go in the PDF. All right, so let's look at triangle CDE really quick. Triangle CDE is this triangle right here. You notice that angle CED has this little box, and that box indicates that this is a right triangle. So that's what we're going to put right there. Now, I'm probably just going to abbreviate RT, okay, right triangle. Let's look at ABE, okay, triangle ABE. ABE, you see these little arcs right here. If they have the same arcs at the angle, that means all those angles are congruent to one another. So that is an equiangular triangle. And then if we look at CFE, triangle CFE, right? All of those angles are acute, at least by inspection. So this is an acute triangle. Let's try to find an obtuse one, like BCE, right? BCE, that is an obtuse triangle because of this angle right here. It looks like it measures more than 90 degrees, okay? I'm not being the best math person right now by just assuming that it is more than 90, but we'll get over it. All right. Let's move down by sides. These are the ones that we're really going to focus on. So we classify by angle, sure, but a lot of the times we are more focused on classifying by sides because knowing how the sides relate to each other is more important than how the angles relate to each other. So using this diagram, we're going to do all three of these. So triangle JKM. So JKM. There's no indication that these three sides are congruent to one another because like JK has this little tick mark right there. KM doesn't have one and JM doesn't have one. So we're just going to go with that this is a scalene triangle because we don't have enough information. Okay. What about triangle KLN though? KLN. Well, if you notice, side KL and side LN, they have the same amount of tick marks on them. So that tells us that these two sides of the triangle are congruent. And look, KN, it does have that one tick mark, but that's not saying it's congruent to the other two sides. So this is an isosceles triangle. All right. And then we're going to have triangle JKN. JKN, if you look, all three sides of that triangle have one tick mark, so they're all congruent to one another. That is an equilateral, okay? All right. Numbers 9 through 14 are pretty self-explanatory. Like, if we're going to classify the triangles by the angles and sides, like for number 10, for example, we see we have an obtuse angle, so this is definitely going to be obtuse. And we're not given any information about the sides, so we know that that's obtuse scalene, right? This one right here, 14, right? You have two sides that are congruent to each other. They both have the same measurement, 5 feet and 5 feet, and then one obtuse angle. So this is an obtuse isosceles, right? So these are pretty simple. If you look at 11, though, this one is all the angles are the same, all the sides are the same. So this is equiangular and equilateral. And fun fact, if a triangle is equilateral or equiangular, then they're the other. So like if you know a triangle is equiangular, then you also know it's equilateral, and vice versa. Okay? So those problems pretty simple. You're not really going to see a problem like that on the EOC. It's too easy. You may see something like this, 15 through 20, right? Looks a little overwhelming, but we can tackle it together. Let's just read the directions, okay? It says, if side PR, side length PR bisects angle SRT, and U is the midpoint of RT, classify each triangle by its angles and its sides. So we need to use that information. PR is a bisector of angle SRT. Well, angle SRT is this big angle right here that I'm highlighting. If PR is the angle bisector, then, let me erase that. Then this angle right here will be congruent to this angle right here. And we already know angle SRQ is 30 degrees. So that must mean QRT. Angle QRT is also 30 degrees. The other thing we know is U is the midpoint of RT. And so here's U, use the midpoint. RT is that segment. We already know that UR is 8 meters, so how much is TU going to be? If they're congruent, it's going to be 8 meters as well. Well, how do I know they're congruent? Well, by the definition of a midpoint is a point on a segment that breaks the line into two congruent halves. So that's how I know those are going to be congruent. All right. So we've taken care of both of these pieces. So let's take a look at triangle UQR. UQR is right here. We see that we have two hash marks, one on UQ, one on UR, so we know this is isosceles. We also see that 120 degrees there, right at angle QUR. So this is an isosceles, an obtuse isosceles. Okay. What about triangle RST? Triangle RST, which is this big one, right? Well, here's the thing. Side SR is 16 meters. Side ST, well, that's 8 meters, 8 meters, that's 16. And then side TR, that's 8 meters, this is 8 meters. So all of the sides are the same. So we know it's equilateral. And we previously said if it's equilateral, it's also equiangular. So that's that one. All right. Triangle SRQ. Let's look at triangle SRQ. SRQ, hopefully you can see right off the back, there's that 90 degrees we got right there. We have no knowledge of side QR, but we do know that SQ is 8, SR is 16. So we know this is going to be a right scalene. All right. Let's take a look at triangle TQU, so number 19. What do we notice? The side TU has one tick mark, side QU also has a tick mark, so we know that that is 8 meters. All the sides are 8 meters. This angle right here is 60 degrees. This angle right here is also 60 degrees because it forms a linear pair with angle QUR. Therefore, this angle also has to be 60 degrees, equilateral, equiangular once again. All right. Finally, triangle PQT. Let's do that one real quick. PQT is right here. Let me erase all these. Well, we don't know a lot based off this figure alone. However, we do know that this angle right here, PQT, will be 90 degrees because it is vertical to an angle that is also 90 degrees. So we know it's going to be a right triangle, and we also don't know enough about the sides to say that any two sides are congruent. So it is going to be a scalene right triangle. Let me stress something for you. It doesn't matter what you put first, the angle classification or the side classification. In the end, as long as you know what type of triangle you're working with, you are set. All right, so I'm going to stop this video here and then start the next video here at classifying triangles in the coordinate plane.